12.3, today we're going to look at velocity and acceleration. So these are derivative concepts. We just did a section 12.2 all about derivatives. And so we're going to take a look at definition first about these concepts. So if x and y are twice differentiable functions, that just means you can take the derivative twice, of t, and r is a vector-valued function given by r of t is x of ti, y of tj, z of tk, then velocity, acceleration, and speed at a time t are given by the following. So the first one, velocity, is just the derivative. Okay, we did that last time, finding the derivatives. No difference. Acceleration is the second derivative, so you find the derivative twice. And then speed is the magnitude of velocity. Okay, we found magnitude back in the last chapter when we were working with specific ordered, like just numerical valued vectors. These are actually function vectors, but it's the same thing. We do the square root of everything squared, each component squared. Now, some of these quantities are really messy. When you square functions, it's not as nice as squaring numerical values, right? It doesn't always work out so pretty. So it doesn't necessarily clean things up and give you a numerical number at the, numerical number, that's good. A numerical answer at the end or something like that. Sometimes it just looks like a mess when you're done. But it can be evaluated at any given t value. So it can give you values if you know a specific point in time that you're working with. So we're going to find the velocity, speed, and acceleration vectors for an example. So we have 2 cosine ti, 2 sine tj, and our point is square root 2, square root 2. And so we're first going to find the velocity vector. So what is the velocity vector? Remember, it's the derivative of position. So what's the derivative of 2 cosine t? Think derivatives. Yeah, negative 2 sine t. And this is the vector I component I. And the derivative of 2 sine t? Don't overthink. 2 cosine t. Yep. 2 cosine t. Okay, so this is our vector. We're going to evaluate these at a point here in a minute, but let's just do all the derivatives and everything first. Okay? Oh, thank you. Get my J in there. Thank you. Okay, so we'll come back to the fact that we're dealing with a particular point in a minute. Okay? So this is velocity. Acceleration, that shouldn't have had a prime there for velocity. I'm sorry. I should have just said velocity. Acceleration vector, which is the second derivative. So what is the derivative of the derivative? So what's the derivative of negative 2 sine t? Negative 2 cosine t. And what's the derivative of 2 cosine t? Negative 2 sine t. Excellent. And then to find the speed, that was the third one. I may have done them out of order, but that's okay. To find the speed, we need to find the magnitude of velocity. Okay, so we're going back to the velocity to do this. So the magnitude of velocity. So we'll have the square root of negative 2 sine t squared plus 2 cosine t squared. Good. Let's try that again. Okay, we're going to figure out the square root 2 still, right? But let's go ahead and simplify this because it's not too bad. If this were uglier, it might be to our advantage to go ahead and find the square root 2 put in first, and we could do it in that order and it would be okay. But generically, we don't always have a point given to us, so I'm going to do it as though we didn't have that point first. So if I get this, I have 4 sine squared t plus 4 cosine squared t. What can we do about that? What's that? You can take out the 4. So what's the square root of 4? 2. And then what? That's just 1, right? That's a trig identity. It's a Pythagorean identity. This actually just ends up being the number 2. So it's actually independent of what ordered pair point we're doing this at. Okay? Now, let's go back and let's actually do this for the square root 2, square root 2. Well, that's great. That tells us the x component and the y component, right? like that's an ordered pair x, y. What do we do to figure out what the t value is that achieves that? Right. So I would need to have 2 cosine of t equal to square root 2, because that's the first component for x, right? And then I would need the 2 sine 2 to be, it should be the same value, by the way, 2 sine, t equal to square root of 2 here. Did I get those pieces in right? Yeah. These aren't negatives.
Okay.
Yep, back to the original. We will, but so far we need to figure out what t is. We're looking for t first. And we shouldn't need to do both of these to find this, mind you. But we could, and we kind of do. So let me explain. Where does the cosine, that was the first one. Where is the cosine of t equal to square root 2 over 2? It's pi fourths. Is there anywhere else that it's equal to that, Adam? The simple answer is yes, right? There's another location within a unit circle that this will equal it. Do you know where it is? It's at 3 pi over 4, okay? And if I keep going around the circle, it'll keep repeating, agreed? Okay. What about at sine of square, hang on, I'm gonna move this up. I'm running out of space. What about at sine t square root 2 over 2? It's also at pi fourths, right? And it has another value too. What is it? It's a 7 pi over 4. So the reality is, no, I don't really need it here. They match in the one that's sort of the most common one for us to have found anyway. But we could have had problems where we thought that one didn't match and the next one did. Yes?
I think we got those backwards. It's not because the x coordinate, so the positive for 7 pi.
You're right. I did get them backwards.
No, that's not that.
This one should be over here. That was an easy fix, though. Yep, the sine value is the three square. They're negatives in the other quadrants, right? That's what's happening. The one where they match, though, is pi over 4. So the t value is supposed to be pi over 4. So when we come back to each one of these, and I think what I'm going to do is I'm going to shrink them so that I have space between them. So if I come back in here and I find v of pi over 2, this will be negative 2 sine of pi over 2i plus 2 cosine of pi over... Yes. Thanks, Adrian. And then I've got my j. All right, what's the sine of pi over 4? Square root 2 over 2, right? So this is negative 2 square root 2 over 2. And then I've got 2, and then I've got another square root 2 over 2 here, yeah? What does this give me? So negative square root 2i, and then positive square root 2j. I have more space on the side than I'm allowing. Okay, is that all right? So this is the value at pi over 4. If I switch that, I'll fix that too. Okay, is that all right? The general one we found before, but then we found it at the specific point, square root 2 over 2 that we were given. Okay, for acceleration, we can do the same thing. All right, so we're going to do the acceleration at pi over 4. So I have negative 2 cosine of pi over 4 I, and negative 2 sine of pi over 4 j. Same values that I keep getting, square root 2 over 2 on each of them. And what do I get? that all right? Okay. If this, I'm off screen now because I moved it too low, but if this had not simplified very nicely to the square root of 2 at the end, or the number 2, excuse me, at the end, or if it had been a mess in the middle of the squaring, we could have taken this right here. There we go, the velocity, and done from this perspective instead of from the function perspective. Does everybody see that okay? Right, this magnitude is supposed to be being found at a specific location. We could have used the specific location and not the general functions for the way the question was originally asked. Okay, let's try another one. Oh goodness, I already did that. That was part B, wasn't it? Evaluate the velocity and the accelerations at the given point. We just did that. I didn't realize I had an extra screen for it. My apologies, we already did that. Okay, so we found them to be, you can fill them in. Velocity at pi over 4 was negative square root 2 I, positive square root 2 j. The speed we found is 2. And then the acceleration vector at pi over 4 was both negative square root 2 I, and then negative square root 2 j. All right, so I crammed it in unnecessarily, so sorry about that. Okay, now you're ready to try another one. New functions, yeah? All right, not all trig on this one. Do notice that they don't give you a point this time, right? They actually give you a t-value. That means we don't have as much to do in the problem. So the question first asks, find the velocity, speed, and acceleration vectors. And then if we take a look more carefully, part B, which is the one I wanted us to do the evaluation at, is to evaluate it at our point t. So we'll do it within the screens they're set up this time. All right, so velocity first. So what is my velocity vector going to be? 3I plus 1j, or you could just write j if you wish, and then plus 1/2 tk. Okay, is everybody good with that? Excellent. It says to do speed. We'll go in order this time. Speed. So to do speed will be to take the square root of each of these squared. So I have 3 squared plus 1 squared. Those are very friendly. And then the last piece is 1/2 of t squared. So if I simplify, what do I get? That'd be 10, and then 1/4 t squared, right? That's not very pretty. If we were to be working in a particular problem, we're going to evaluate this in a minute, and it might be nice enough to leave it like it is. But having this underneath a radical and merged like this, if we wanted to clean this up a little bit, a good way to do that would be to get a common denominator. You'd get 40 plus t squared over the 4. It would be square rooted. And then you'd have the square root of 40 plus t squared over 2. Okay?
Why would we do that step, though?
Because you've got a radical that's got a denominator. I didn't say it right. You've got a denominator that's got a radical in it, is what I meant to say. Essentially because there's this 4 in the denominator down here.
But since we're just going to put t in, do we have to go?
We are for part B. So if they asked you to do it all in one step instead of separate it out, then you wouldn't necessarily need to. We'll evaluate it from our first one probably when we get to part B. So yeah. I think we have one more. Acceleration, right? All right, so what is our acceleration vector going to look like? Yep, just 1/2 k. All right, so it's only accelerating in the k direction. Everything else is constant. All right, and then part B is to evaluate them at the t value, t equal to 2 that you're given. So we had our velocity vector, and part of our velocity vectors were already constants, right? The 3i and the 1j, or just the j, those are already constants, so we don't really gain anything by evaluating it that one. But the other one we do, we have 1/2 times t, which is 2, and then k. So this is 3I plus j. And then we have plus k. Okay, so that's my velocity vector. And then my acceleration vector, right? There is nothing in the i's, there is nothing in the j's. And in fact, there's even nothing for us to put in for t and k direction. It's still just 1/2 k. So it's not a very exciting one to evaluate this at. And then for this one just says the velocity and acceleration vectors at t. It doesn't list it, but let's do it for good measure. Let's do speed, since I had mentioned to Adrian that we would. So this one is going to be the square root of 10 plus 1/4. It's t squared, and t is 2. So what happens when we have 2 squared and 1/4? That's 1. So this gives me square root of what? 11. It didn't technically ask for that one, but it could have, right? Sure, of course. All right, ready for one more? All right, so we're going to use the acceleration vector tj plus tk. The velocity vector evaluated at 1 is 5j, and the position vector evaluated at 1 is 0. To find velocity and position vectors, and then we're going to find the position at t equal to 2. Now, it doesn't actually say what kind of problem this is in the sense that there's no words for it, but can you tell me what kind of a problem this is? No. We're going to integrate. Yeah. What else? It has definite values. What does that mean we're going to be able to do, Adrian? You're right. What happens generally when you take antiderivatives?
You have C.
You have a C. And what does this tell you is going to happen?
The C's not going to be there.
You're going to be able to find the C. So the category of problems that this put this in is called an initial value problem. They give you some kind of a value. I don't know why they call it initial value. They just give you a value. And that value that they give you allows you to figure out what C is. Okay, so this is an initial value problem. So let's start out with the acceleration vector that they give us and go from there. So I know it doesn't have it, but I'm going to write it in anyway. This is 0I plus tj plus tk. All good? All right, so using that, going backwards, what would the velocity vector be? Close. Not ti. Ci, some constant, it's some number. Think about going backwards. If you took the derivative of a number, you get 0. So when you have 0 and you take its antiderivative, you get back some kind of constant. Now, what about the middle one, t, j? That's t squared over 2 plus some c2 value, right? J. And then same thing for k. T squared over 2 plus c3k. All right. And it tells us here what happens at one specific value. Whoops. Here it is for velocity, right? It tells you if t is equal to 1, I get 5j. So if I put in 1 here for all my t's, c1i plus 1/2, right? I'll just write it in as 1/2. 1/2 plus c2j plus 1/2 plus c3k. It's going to equal 5j. Okay, so we need to figure out what C1, C2, C3 are based on that fact. So what is C1?
0.
Yep, it is still 0. What is C2?
4.5.
It's 4.5. So I'm going to write down 4.5 like that, but we are going to recognize that that's the same thing as 9 over 2. Since we're dealing with decimal fractions already, we're going to write it as 9 over 2. What is C3? negative 1/2. So what I currently have now for my velocity vector, based on that initial value that they gave me, is that I still have, and I'm going to again keep writing it as 0 because I'm going to need it in a minute, 0I plus, and then I have t squared over 2, and then plus 9/2 j. And then I have t squared over 2 minus 1/2 k. Okay, is everybody good so far? Mostly all right? Okay, so we're about halfway there. It says we're going to do the position vector as well. So position vector means that we're taking a look at R. Hang on, I want to see if I can copy this to the next page. Oh my goodness, we don't want a white screen. That's not going to be helpful at all. Hang on. Let's at least do that. All right, there's my velocity vector. All right, so let's find position vector then. My position vector, okay, what's the antiderivative of 0I? C1I, right? You're going to get a constant back at least, potentially. T squared over 2. T to the third over 6 is correct. 9/2. 9/2 t plus c2 first, and then j hat. All right, we got the t squared over 2 again, so now it's n t cubed over 6. 1/2 is 1/2 t, and then plus my c3. Okay. And it tells me, back at the beginning, that r of 1 is what? What's it say? It's supposed to be the 0 vector, right? So if I put 1 in everywhere, we should be getting 0 vectors. So C1I plus, I'm going to put the 1s in everywhere first, 1/6 plus 9/2 plus C2J plus 1/6 minus 1/2 plus C3K. And these should all, it should be the 0 vector. Let me shift this over and I can write that on the side. This is the 0 vector, right? So all of those coefficients for IJK should be zeros. So this should be 0. That's easy enough. That means C1 is 0. All of this is 0. That's a little bit messier to do. So somebody grab a calculator or scratch paper real quick, or maybe you can just do it quickly in your head. I don't know. What is 1/6 plus 9/2? What is it? 28 over 6. Do we confirm that? Okay, then what would C1 be, or C2 be? C2 is negative 28 over 6. Can we simplify that? Yeah, negative 14 over 3. They're both even. How about 1/6 minus 1/2 plus C3? What is that, Sophia? Yeah, negative 2/6. You got negative 2/6 and then you said 2/6. Is that what you're telling me? Yeah, I agree. And then simplified, you would get 1/3. So our position vector, R of t, is going to be, at this point, if you don't want to write the 0I, you're welcome to not write it. I'm going to still write it, but you could write just nothing there. And then we have t cubed over 6 plus 9/2 t minus 14/3 j plus t cubed over 6 minus 1/2 t plus 1/3 k.
That just doesn't even look nice.
It doesn't look nice. We're actually still not done either.
Oh.
Go back to all your directions, see where we are in the process. Make sure we see all the pieces. What does it say? Yeah, it says that we're supposed to evaluate what at 2? Velocity and position. So we need to find V of 2 and R of 2, right? So I do still have V on my screen. So we're going to do V of 2 first. So it's at the very top. I'm still going to get 0I. Write it or don't. And then I need to evaluate t squared over 2 at 2, which is going to give me what? 2 plus 9/2. 13/2. So 13/2 j. I assume it's plus, maybe it's not. Let's see, we plug in 2 for t squared to get for t again. So we get another 2. 2 minus 1/2 is 3/2, right? Okay. So this is our v of 2. V of 2. And then our last one we're supposed to do is r of 2. So r is towards the bottom. We've still got another 0I. All right, now you've got 2 cubed over 6. Now things are worse. I'm going to have to jot it down to the side if I'm going to do it with you at all. So we've got 2 cubed is 8. So I have 8 over 6 plus 9, because it's 9 over 2, minus 14/3. So what is 8 over 6 plus 9 minus 14/3? Somebody grab a calculator. Huh?
9 minus 10 thirds.
It's 9 minus 10/3? Oh, because okay. Gotcha. Adam's exercising mental math right now. It's very good skills. That's what I have written down, so I think you're probably right. Sophia's going to check for us and see if the calculator agrees. Did you get 17/3? Wonderful news. All right, 17 over 3j. And then we're going to do the same thing here. So we have 8 over 6 minus 1, and then plus 1/3. 2/3 sounds right. So we have 2/3. Okay. So I'm not going to even box it in. We had lots of things it asked us to find. We found all of them. Right? So we found all of the individual pieces, and we found the final part, which was to evaluate them, put them in the 2. All right.